Okay, a boy wants to throw a ball over the roof of the barn. He can throw with an initial speed of 15 meters per second, and I want to find what angle it must be thrown at so it reaches its maximum height right there at C. Okay, and then find that distance, basically from the barn that he needs to do. So basically, what I'm interested in is this point right here. Okay, at that point right there. And again, I usually start with my horizontal um, equation because that's again what makes it a projectile here. So this ball travels from A to C. It travels d plus 4, okay, after starting at a position of 0, my initial position, okay, and it's launched at in the horizontal direction. I know it launched at 15 meters per second, but that'll be cosine of that angle for the horizontal, okay, and it'll travel a distance or over a time of t. Okay, so basically I have three unknowns, so I'm going to need a couple of more equations to figure this guy out. Okay, now I'm going to go, since I know that position. Okay, I'm going to go ahead and I'm sorry, since I know the velocity. Okay, okay, the final velocity, I'm going to use the velocity equation in that my final velocity here is 0 where in the vertical equation, whereas my initial velocity is going to be 15 sine of that theta a, okay, and my gravity or my acceleration again is negative 9.8 t. Okay, so again, this is again my velocity in the y direction plus my initial velocity in the y direction minus, well, we'll just call it gt. Okay, so that's where this equation's coming from. Okay, now the other one that I can use, okay, well, actually, no, the other one that I'll use is the one without time in it at all. Okay, which basically I get v1 squared equals v naught squared minus 2g, and then that'll be basically y minus y naught, like so. So my final velocity is 0 because again, I just want it peaking at point C there. So I'm only going to have a horizontal velocity at point C there. Okay, so that velocity, that vertical velocity again, is going to be 0. Okay, my initial velocity is 15 times sine of theta A squared, okay, minus 2 times 9.8. And again, my position here, my final position is 8 meters. My initial position is 1 meter. So again, using the fact that I want my curve to peak there, so my velocity at that point is 0, I can figure this out. I know my positions, I know gravity. The only thing I don't know is the theta. I can solve that theta using probably a calculator. Um, 51.3 degrees. Okay, now the other thing it wants to find is the distance traveled. So from the distance traveled, I can then plug this guy up into that second equation, find my time, where my time is going to be 1.195 seconds. Now that I have that time and that angle, I can plug it into the top equation and find that the distance that the boy needs to stand away is 7.2 meters. Okay, so again, with these projectile problems, I usually start with my horizontal um, equation because I'm almost always going to need that one. And then from that, I talk about what I know. In this problem, I know that it's peaking at point C, so the vertical velocity is going to be equal to 0. Okay, and I use that to my advantage to help me find the time and the angle that I need to throw at to get the peak to occur at point C there, and then calculate what I need to from there.